Now we'll discuss electric field. So electric field vector E vector. So we'll put a we'll put a source charge. So if here is a source charge Q, so it will produce electric field. Electric field which is spherically outward. If it is a positively charged, then electric field will be spherically outward in all direction. This is called source charge. So if we put a test charge in this field Q naught, this is called test charge. So it will experience the field. If it is a positively charged, so it will experience the field and it will feel the force away from the charge as they are of same polarity. So it will experience a force F vector. So this is a two-step process. The source charge will create the electric field. The source charge will create the electric field which is spherically outward. And in this field, if you put a test charge, it will experience the force, experience this electric field and feel the force. So the expression of force, F is equal to Q naught times electric field vector. So the unit of electric field vector is Newton per Coulomb, or sometimes we write it as volt per meter. So what is the dimension? So the dimension of electric field vector is equal to, electric field is, from this equation it is clear that electric field is equal to force by the charge Q. So the dimension of the force divided by dimension of the charge. We know force equal to mass times acceleration. From that expression, ml t to the power minus 2 divided by at. So the dimension of electric field or electric field intensity is equal to ml t to the power minus 3 a to the power minus 1. So this is the dimension of electric field, or sometimes we call it as electric field intensity. So electric field intensity due to a point charge. So here let us consider the charge, point charge plus Q at the point O. So we will calculate the expression of electric field at a distance r at the point P. What is the expression of electric field is equal to what? And also what is the expression of force at this point? So we'll take a test charge Q naught. We'll take a test charge plus Q naught, right? So according to Coulomb's law, we know force between these two charges will be, force is equal to 1 by 4 pi epsilon naught Q naught by r square. This is the expression of force between these two charges plus Q and this plus Q naught separated by distance r. So the expression of electric field will be simply force divided by this test charge, which is equal to 1 by 4 pi epsilon naught Q by r square. Unit is Newton per Coulomb, and the unit of force will be in Newton. Now, if it is in a medium, then the expression of electric field intensity will be 1 by 4 pi kappa epsilon into Q divided by r square. Kappa epsilon naught into Q divided by r square, where kappa is the dielectric constant in a medium. This is in a medium. But for vacuum, the dielectric constant K is equal to 1. This is for vacuum, or in air, the value of K is equal to 1. So now if we write the expression of electric field in vector form, then electric field will be is equal to 1 by 4 pi epsilon naught Q divided by r square into r cap. This is the unit vector. So electric field will be, r cap is unit vector along this direction. So this is r cap. So this is the expression of electric field. This is the expression of electric field between two charges. Now, if there is a group of charges, now the electric field, the expression of electric field due to a group of point charges. So if there is more than one charge, Q1, Q2, Q3, so on and so forth, what is the expression of electric field at the point P? What is the expression of electric field at this point? So electric field will be electric field vector is equal to electric field due to the charge Q1, that is E1 vector, plus E2 vector, plus E3 vector, plus dot dot dot, plus En vector. So this is the summation. So this is the addition. This is the summation. So electric field, the expression of electric field is equal to 1 by 4 pi epsilon naught summation over I is equal to 1 to n Qi by Ri square by into Ri cap. So this is the expression of electric field. So this is the expression of electric field at the point P. At the point P, what is the expression of electric? So this is the expression of electric field at the point P, which is equal to 1 by 4 pi epsilon naught summation over 1 by 4 pi epsilon naught the summation I equal to 1 to n Qi Ri square into Ri cap. If for the charge Q1, it will be Q1 by R1. For the charge Q2, it will be Q2 by R2 square, so on and so forth. So this is the expression of electric field. Now, so electric field varies. Electric field is proportional to 1 by R square. Electric field is proportional to 1 by R square. So the variation of electric field E, electric field intensity with the distance is this way, 1 by R square. That means electric field is proportional to 1 by R square. That means when R tends to infinity, electric field tends to 0. And when R tends to 0, electric field intensity tends to infinity. So that's why when R tends to infinity, electric field tends to 0. And here, when R tends to 0, electric field tends to infinity. And here, when R tends to infinity, electric field tends to 0.